Hey, hi everyone. This is the second video on low level design of Google Maps. So in the previous video we are talking about of dividing the entire globe into regions. So how we are going to do that? And also I am going to talk about why we need to divide globe into regions. But before that, how we will divide the globe into regions. So first we need to know what's latitude and longitude. That uniquely, so these latitude and longitude are used to specify any point on Earth uniquely. So latitude is nothing but, so if this is the globe and this is the equator and this is the center of the Earth. So if you imagine a plane that is passing through the equator and the center of the Earth, and then if you take any point on the globe, and then if you draw a line from center of the Earth to that point, and then the angle made by this straight line to the plane that is passing through equator and the center of the Earth is latitude. And then the longitude is, if this is the south pole, this is the north pole, and then this is the south pole, and then in London, in England, we have a point called Greenwich. So through which, if you consider a plane that is passing through these 3 points, and then this is the point for which you want to measure the latitude. Now imagine a plane that is passing through this as well, north pole, south pole, and then this point. Now the angle between these two planes is latitude. So this is longitude. The angle between these two planes is longitude. So with latitude and longitude, we can uniquely represent any point on the plane, on the globe uniquely. Now how we will divide Earth into regions? So for example, you say there is this is a region on globe, and this point is say 53 degrees longitude, and then 55 degrees latitude. So 53 degrees longitude and 55 degrees latitude. And then now imagine this is this is square with 1 degree on each side. So this will become 52 degrees latitude and then 55 degrees longitude, and then so on. Like each side of the square each side of the square is 1 degree. Now break this square into into 4 columns and 4 rows. So each of this square is a region that we are going to consider as a region. That is what I mean by each region in our Google Maps. So why do we need to divide these into regions? So this will help us to find the shortest point from any location. I will talk more about that, like what is the shortest path, like shortest distance point, and we'll discuss more about that later. So for now, like we have divided this way, like into 0.25 degrees side squares. So first, to add a straight rule, which is a sequence of coordinates. So first we need to, for each of this coordinate, first what are all the validations that we need to do? So first we need to validate whether these coordinates are actually on the road, not on some not on a plot, right? It should be on the it should not be on a plot. So for us to identify, so as in the previous video, as I said, like the globe has plots and then roads. So these are the two things that the entire globe has. Even if you have a water body, then you will still consider it as a plot. So the point, so now we want to add a straight road, right? We want to add a continuous road, not a straight road, but it can be a curvy road as well. Now we want to add a continuous road on into the maps. So the first validation we have to do is each and every coordinate on this continuous road should not lie inside a plot. Should not lie inside a plot. So if it lies inside a plot, then the data that then the path, then the road that we are trying to add is not a correct road. So first we have to do this verification. To do this verification, we need to have plot data into our Google Maps. So how we are going to represent this plot data? So plots are represented in feet, not in meters. So the perimeter of this plot, I will have coordinates every 1 feet, that is approximately 0.3 meters. So if I have a coordinate of this, say this point, then after 1 feet, 1 feet distance, I have this coordinate. So I will mark an edge. I will create an edge from this point to this point, which are separated by 1 feet. So this way I will save entire data of this plot, just the perimeter coordinates. That is what all I need, so that I can precisely represent this plot. So here in our low level design, to save this data, we have Gmaps database, so which is a singleton class, which can be used by Gmap service as well as Gmap service helper. So in this we are saving all the data. So each plot can fall into multiple regions. So multiple regions, and we will represent each plot with a unique plot ID. So what I mean by that is, this plot will have one unique ID, and then this plot will have another unique ID, and then if there is some other plot, this plot will have some other unique ID. So each plot is represented uniquely. And then so here we have this this map that stores this data, like for each plot ID to ordered coordinate list. So what this means is, this map will have the plot ID, and then it will have list of coordinates. So this list of coordinates, so this is the list of coordinates. These are in an ordered way, not in some random. The coordinates are not jumbled. So what I mean by ordered is, if this point is P, and then this is P1, in the list we will have, after P we will have P1, and then after P we will have P2, and then so on till Pn. So this is the Pn, which is just behind P. So this way we will have this continuous list of coordinates of the plot. And then in the plot, in these coordinates, if you see the representation of coordinates class, so in coordinate class we have plot ID as well. If the coordinate belongs to plot, then we will set is it a plot as true, and is it a road as false, and then we will save the plot ID as well, to which this coordinate belongs to, and then the region to which this coordinate belongs to, and then the longitude, latitude, the address of this coordinate. So all this information we will save into these coordinates. So these coordinates will have all this information. And then also plot perimeter coordinate by region. So by region, so for each this map will have for a region what are all the plot coordinates that it has. What I mean by that is, so this is a region, right? So this region has different plots in it. Say, so this entire this plot belongs to this plot belongs to, this is a region. So all these coordinates, this coordinate, and then these coordinate, this coordinate, and these coordinates, these all fall into this region, but not these. These fall into a different region. These are in different regions. So we won't have them in the same map. So each region we are representing by a coordinate that is towards the north and then towards the west, right? So this coordinate, if you imagine, this is towards north and then towards west, then that coordinate we are going to represent each is used to represent each region. So in the map for this coordinate we are going to have this a list of coordinates of the plot, and then the list will have all these coordinates included in them. This should not be any order particular. It can be in any order. The order need not be continuous, like how we are storing for id to ordered coordinate list. Okay, so this is how we represent plots, and how we save the plot related data. So once we have this, imagine that we already have, like, consider that we already have this data. Now how do I find, given a coordinate, if it lies on a plot or not, if it lies inside a plot or not? So to find that, so consider a point which is here. Now what I will do, from this point I will consider a radius of 0.25 degrees, and then see what are all the regions that fall into. So the regions that fall into is all these 4 regions. So all these 4 regions fall into this this radius, the radius from this point to 0.5. all this you see the circle will be like this, right? It has a 0.25 radius from this point. This is the point we want to find whether it is inside a plot or outside of the plot. Now what we do, we compare this point with all the plot coordinates in all these regions. So where do we get all those coordinates of plots that lie inside these regions? We can get it from this map, plot perimeter coordinates by region. So this map will have for each region what are all the plot coordinates it has inside. So now we will compare all those coordinates and then find which one is the nearest coordinate. So now we found that this is the nearest coordinate. This plot in this region has a coordinate that is nearest to this our interested point. Sorry, this looks all like everything is falling on the same point. Let me clear this so that it would be easy to understand. Okay, so this is our plot, and then this is the road. So now this is the point of interest for us. This is our point of interest, and then we found that this coordinate on this plot is the nearest point. So now whichever one is the nearest, that we will consider as the plot that has this point inside it. So now I will consider that this point is inside this plot. So how do I prove that? How do I prove that this point is inside this plot? So what I will do, for the same equator, for the same latitude, so this is the same latitude, I would see what are all the coordinates that are falling on the plot. This I can get from this, like ID2 ordered coordinate list. This will have all the coordinates of this plot, and then I will see and then I will find this coordinate and then this coordinate. So once I find these two coordinates, then I need to see if actually this coordinate is lying in between. So now we see it is not lying in between, it is outside. So that means this plot, this point of interest that we are looking for is not inside the plot ID. So that is how we confirm that this is not actually inside a plot, and then we can consider that safely as a road, a coordinate that is on a road. So this is how we are going to, this is the basic idea, like how we are going to verify each and every coordinate on this road. So once we verify all these coordinates, all these road coordinates, now we need to add these edges and then the coordinates into our database, so that it can be used to represent our maps. So how do we add each and every, how do we preserve this information of these edges and then the coordinates of the road? So as we said, like we have divided entire globe into regions. We need to have in this region, for a given region, we will have an adjacency list. Adjacency list is nothing but, for given a coordinate, what are all the edges it has, and then what are all the adjacent coordinates that it can travel. Like from a given coordinate, what are all the adjacent vertices that will be saved into this road adjacency list by region. So for a given region, we will have again a map of coordinate. This is an adjacency list. This map is an adjacency list, and then this map, the above map, will have region to adjacency list map. So not only that, we also have road ID to list of coordinates. So I haven't mentioned that here. Add attribute road ID to ordered list, right? This would be a map. First would be a string, that is road ID, and then we have list of ordered coordinates. So for a given a road ID, then I will be able to know what are all the coordinates it has. This is an ordered list. Not what I mean by ordered is, if this is a road, and we have point A1 and then point A2 and then point A3, in our list we'll have, after A1 we'll have A2, and then after A2 we'll have A3, and then so until AN. So we'll have ordered. But not like once we have A1 first and then A3 second and then A2 next, not in a jumbled fashion. We will have it in an ordered way. Okay. Why we need to have that in an ordered way? I will explain all those, like why I have made those decisions. So now we need to add that straight road, right? So what do we need to do? Like we just need to update these two fields. Once we update these two fields, that's it. We have added a map successfully, like a road successfully. So you can read this point. Once all the road coordinates are verified, we need to update the road adjacency list by region and also update the id to ordered coordinate list. Road id to ordered coordinate list. Okay, thank you. That is for this video. In the next video, I am going to explain about add junction. So add junction, to give a brief about what this add junction function is, when we add a new road, this might create a junction between two roads. It might two roads might intersect at a point, and then that point is considered as junction, and we need to use that to represent maps. That junction point is used to represent maps, so that from that point there is actually four ways to go. Like from that point we can either go to up, down, like if it is a junction we can move in four different directions. So all that information need to be preserved. That we will be talking in next video. Thank you.